and I'm going to share my screen. Let's see. Okie dokie. So everybody should be able to see my screen now. And I wanted to do two things tonight. I wanted to talk about lists and dictionaries, which is Module 6. But in Module 7, you guys are going to have to do your projects. So I wanted to spend some amount of time tonight, and it means we may go over some, to go over the requirements of the rubric and talk about the different things from a Python perspective that you will need to do to have a successful project. And so we're going to just kind of introduce that, and then if next week anybody has any questions associated with that after you've had some time to get into your projects, you can let me know, and we might be able to work through some of those issues here. So to start off with, tonight we are doing Module 6, and this is lists and dictionaries. Lists and dictionaries are what are called collections. And basically they allow you to group information in ways that make sense to you. Lists are very structured in the way they group information, and they have a very structured way of reading and writing the data. Dictionaries are more unstructured, and you kind of decide the structure. And both lists and dictionaries have pros and cons, like just about every other construct in programming, and we will go over some of them. As a foundation, there are 4 things you can do with a collection. You can create it, read it, update, and delete. Those are the 4 things you can do with elements in a collection. And it's an acronym from way back in the database programming days that I used to do, and it's called CRUD, Create, Read, Update, Delete. So if you get into a quandary about what you can do, just think about that. Create, read, update, delete, CRUD. So why do I want lists and dictionaries? Well, because I want to associate data. Sometimes I want to associate data with other data in the form of a list. Let's say it's, a list of my favorite songs, like a playlist. And sometimes I want to associate things with what we call key value pairs, and we'll get into that a little bit more when we start talking about dictionaries. But basically you want to associate data, and you want to keep all of that data in one place. And the place where we keep data is variables. So I can create a variable that's a list or a variable that's a dictionary, and I can do all kinds of cool stuff with it. So let's get started with a list. So they're going to tell you that a list is an object type, just like everything else in Python. Okay? Just like an integer, just like a string, they're all object types. And as such, there are things that Python gives us that we can do. First thing you can do is you can create a list. So I'm going to, just start with PyCharm, and I'm going to create a new file, and I'm going to call it simple list. And use this. Edit my configuration. Okay, and I'm going so I can run simple list. And all I'm going to do here is I'm going, the configuration, well, it's there. I do not like, I know you've heard me say it 100 times, I don't like this new PyCharm. Anyway, so I'm going to get back to writing a simple list. So I'm just going to call this simple. And I'm going to do that. Now this is interesting. Let's make this bigger. case people, whoops, sorry about that. Okay, so what did I do here? I have a variable called simple. I know it's a variable because it's on the left-hand side of a single equal sign. On the right-hand side, what do I have? I have a left square bracket and a right square bracket in that order. So what have I told Python? What I have told Python is that my variable simple is going to be a list because the left square bracket and the right square bracket in that order denotes to Python that whatever is inside is going to be a list of things. Now right now simple is an empty list. So if I printed simple and I ran this, I would get just what I put in, nothing in the list. Now, when you are printing a list or a dictionary, it's going to look different than when you're printing, let's say, a string. Because since Python knows this is a list, it's going to always act as if it's a list. So when you're printing it out, you're always going to get the left square bracket and the right square bracket at a minimum. So you don't have to worry about whether, so I'm saying this because sometimes people they print out a list and then they're like, why do I have these square brackets? And that's because that's what Python does. You have no control over that if you're printing an entire list from the variable. Now there are other ways to print things, and we'll get into those. So that's great. I have an empty list. How do I add things to the list? Well, I can just add, let's say I want to add a number. So now I have a number in the list. Let's say I want to add a string. So now I have two things in the list, as you can see down here in the console. And I'm going to add 99. And I'm going to add a float. So what I've shown here is a couple of things. One is that I can add lots of different things to a list simply by putting that thing in the list and adding a comma between whatever it is and its next thing. So in this case, I started off with an integer, I added a string, and I added a float. And now I have commas in between. That's the other construct for a list. I separate individual elements in a list with a comma. That's just how it's done. There's no other character that can do that in Python. If you have a list and you want to put things in a list, you separate them with a comma. Now you'll notice that this last element in the list does not have a comma after it. You only need to put commas between elements, not after the last element. So that's what a list is. And we'll go through and look at a couple of things about lists because there's lots of interesting things you can do. Python gives you functions you can do on a list, and there's all these things that are just inherent in it. One of the things that's inherent in a list is how you get to the data in the list. Because right now, I'm only getting to the elements in simple with this print statement. So I'm printing everything in the list with its square brackets and all. But I don't have a way, at least not at this moment, of getting at the individual elements in a list because one is an element, this is a string in quotes is an element, and 1099 is an element. So how do I get at those individual things? Well, there's a way to do that. And the way to do that is by an index value. Every list in Python has an index value starting at 0 and ending at 1 minus the length. And we have for loops. And we have a range function in for loops. And I can use those two to look at the elements of a list very quickly and easily. So I'm going to comment out, print simple here, but I'll do it here so that I'm going to say for element in simple. So this is one way of doing it. Actually, now I'm going to do it differently. For index in range 0, and it's simple, because we know that range always does the last number minus 1, or the length minus 1. And then I'm going to print so what have I just done here? Well, I'm using a for loop. Now, for loops and lists were made to go hand in hand. If you're thinking about iterating through a list, the first thing you want to think about is a for loop. You can use while loops, that's completely okay, but for loops you will end up writing less code most of the time if you use a for loop. Now I've got this thing index here. Well, index is just a variable that's created for use inside the loop, like we found out when we were doing for loops, when we were learning about for loops. But here, this index has kind of a special meaning because of the fact that we're doing a list. This index is the position in my list of the value. So what do I mean by position? Well, this has got the first position in the list. This element has the second position in the list. And this element has the third position in the list. However, I started my range at 0. Why did I start my range at 0? I started my range at 0 because every list in Python always starts at 0. You can never start it anyplace else. You begin by starting at 0. So this is the 0 position. This is the 1 position, and this is the 2 position. So while I have 3 elements in my list, if I want to get at them, I go and get, starting at 0, then I go for 1, and then I go for 2. And we can see that when I run this, because it's simple, and the way you read this is of. So simple of 0 is 1. Simple of 1 is, this is a string. Simple of 2 is 10.99. So this is how I get to an element in a list. Now I can also do it like this. I can also say, if I know that I only ever want to look at the element at the 0 place in the list, then I can do that too. So I can just print that again. It's just going to print 1. So I am using the index value, and I'm going to get to the element in the list and the value of the element in the list by using that index value. So let's go back. I think I covered all of that. And by the way, as always, let me know if you stop me, ask me questions. There are list operators, and they're very, very handy. We already talked about just the print for my list that creates a list. Creating a list. You can also create a list using the list function. I've never used it because I've always created it with square brackets. There's nothing wrong with it. What this will do, however, is this will change the format of your data. So it's always going to put commas in between them. So you'll have You won't have number 1, number 2, number 3 as you see in this example. You'll have the string 1, the string 2, and the string 3. We talked about getting an element from a list. Create a new list containing some of another list's elements. So you can take a list and pull out some of the elements and create a copy with some of those elements. And you do that by giving it a starting position and an ending position. So an index where it starts and an index where it ends. You can add two lists together. You can modify the value of an element in the list, and we'll show you that in a second. Let's see, you can get the length of a list using len, and you can remove a list by saying, you can delete an element in the list by using the del operator for a list. So I do want to go back, and I want to show you that lists are mutable. What does mutable mean? Mutable means that a list can be changed. The elements in a list can be changed. When we were talking about strings, we talked about a string being a list of characters that was immutable or cannot be changed. A list in this form that you can put anything in can be changed. So how do I change it? Well, I can say simple of 1 is going to be, going to equal, I don't know, 400. And then I can print So actually, let me do this. Let me print. I'm going to print it before. I'm going to print it, I'm going to change it, and then I'm going to print it after. So you'll notice that these two print statements are identical. So you would think that the same information will show up on the screen, but that's not the case here because I have changed the value. So if I run this, we'll see this is a string and 400 here. So this is a string, is element 1 in the list before I change anything. I go ahead and change it, and that same line, it's the exact same code, now has 400. Well, I didn't change anything in the print statement to print 400. I changed the value at a position in the list, and I changed it at the 1 position, which is going to be here, because this is the 0 position, the 1 position, and the 2 position. So that's how you change things in a list. Yep. Lists can be named anything. Yes, lists can be named anything. Any valid variable name, you can name a list. And in fact, lists can contain other lists, and lists can contain dictionaries, and dictionaries can contain lists. You can mix them up however you want. And if there's any labs you guys specifically want me to go over, we will go over them. Okay. So modify short names by deleting the first element and changing the last element to Joe. So just because we were talking about this stuff, we'll do this one really quick. Yes. Can you do labs 13 and 19? I will try and get to labs 13 and 19 tonight, Luke. Okay. I just lost what that was. 6.1.1. Okay. So this is just, I have a list. Just do all of that. Okay. I'm not going to worry about the user input. I'm just going to have my list in there. So I'm not going to worry about the user input for this one. I'm just going to say there it is. So that's my short list of names. I'm just using what they have, and I'm not worried about the input. You guys have done that enough. You get that. So what it said they wanted me to do is they wanted me to delete the first element in the list and change the second one, and change the last element to Joe. Okay, sorry. The sample input is Gertrude, Sam, Ann, and Joseph. So let me do that. Okay. So Gertrude, Sam, and Joseph. So I have 4 elements in my list. They want me to come up with 3 elements, and the last element should be Joe. So what do I do? Well, I have this operator. So let's start with deleting the first element in the list. I can say del short names of 0. And that's going to get rid of Gertrude. And for right now, I'm just going to print, every time I make a change, I'm just going to print it. Print short names. And then they want me to change the last element to Joe. So I'm going to say short names of what? Well, how many do I have in there? If I had 1, 2, 3, 4, and I deleted 1, I now have 3. So I would have 0, 1, and 2. So at 2 is going to equal Joe. So let's see what happens when I run this. Let me change my configuration. Okay, and run it. And you'll see that, oh, let me print it before then. So let's run it again. It started out with Gertrude, Sam, Ann, and Joseph. I then got Sam, Ann, and Joseph after doing this line of code. And then I got the final, which was Sam, Ann, and Joe after Python did line 11. So that kind of shows you how you can manipulate a list. And that's what 611 is. It's just about introducing you to manipulating a list. Now, there are methods you can do on a list. And we just saw you could delete it. You can also remove an element from a list by the remove. One of the ones that I use most is Append, because I don't always know what my list data is going to be. If I am pulling list data from a database, let's say I've done a database query and I've got all this stuff back, and I'm going to go through it and I'm going to pull stuff out and I'm going to put some of it in a list. I may not know how many elements in a list I need. Well, then how do I create a list? Well, I use a function called append. And append just says add a new element to the list and stick it on the bottom, and stick the next one on the bottom, because that's what an append does. It just takes a collection and it gives you a new value, and it just adds it to the very bottom of the list. Extend allows you to take another list and add it to the list you're working with. It's very handy, so you don't have to go through, a for loop to get each element in the list. You can just add the whole list. Insert says add an element into the list before whatever the position is. So I don't have to rearrange the list. I can just go to that position and slot in an element. And I can remove an element from a list with a value, which is great, because maybe I don't know what element number is, but I do know what the value is I want deleted. So I can go through that list in a for loop, and I can just delete an element from the list by its value. Pop basically says, give me the last element in the list and get rid of it. And this is used for when you're doing stack algorithms and stuff. And pop I just means remove an item from the list and give me the value for that item. So you want to get rid of it, but you want the value for that item at that space. You can sort a list. You can do a reverse sort on a list. There's indexes and counts. So there's all kinds of interesting things you can do to a list. But what I wanted to show you real quick was how you create a list from, and we'll just use simple list. How you create a list, well, I'll just do a new one, from nothing. So I'm going to say create list, and I need to change this. There we go. Create list. So here what we're going to do is we're going to create a dynamic list. And a dynamic list is just a list. I don't know what the values are yet. So I'm going to say dynamic is an empty list. Because I always have to, I'm going to have to tell Python it's going to be a list, but it's an empty list. So I just want to populate dynamic with, let's say, integers. So I'm going to say for I less than range of 1, 100. Let's just do 10, actually. I don't need to do that. In. Wrong language today. I. And here I'm going to say print and then I'm going down here, say print So what do I have here? Well, I have an empty list. I created an empty list on line 2. I'm just, for the purposes of this, I'm showing you what is going to happen before we get, what does dynamic look like before we get into the for loop? I have this really simple for loop which just rolls through and use the append function to add things to dynamic. And then I'm going to look at what dynamic is when I'm done. So I'm going to run this, and we will see before the for loop, there's nothing in dynamic. After the for loop, there are 9 elements in dynamic, starting at 1 and ending at 9 because I didn't start it at 0. But using this append, I can add things to my list, and I don't have to know what the values are beforehand, which is extremely powerful because that means I can create it dynamically however I need to. Okie dokie. Okay. Iterating over a list. We already talked about that. And there are a couple of different ways to iterate over a list. One is what I showed you in simple list, which was we use the value of the index. The other way is to just iterate over the list, which is actually a little simpler. And so I'm going to say for item in dynamic, and I'm just going to say print item is item. So this is actually a little simpler than what we did in simple list. In simple list, if we go back, I said for index in range 0 of len simple, and then I printed it out. Well, it looks pretty simple. But in fact, this is a little simpler because there's no range or length or anything. And more importantly, there's no way to walk off the end of a list. And I'll show you what walking off the end of a list means in just a second. And I'll show you the error that'll happen. So this just basically says, just for everything in the list, just go through that list. I don't need to know how long the list is. I don't need to do any ranges. I just want to go through the list. So, you know, it's really great because it's 4 words and a colon. Oops, what did I do? Attribute stir object has no attribute. Oh, format. It helps when I remember what the function name is. So here we did. We just went through and it said item is 1 through item is 9. So that was extremely simple, and it's quick, it's simple, it's easy. And Python directs you in the fact that you don't have to worry about how long the list is or anything like that. It just is. Now, there are some errors that can happen when you're accessing information or data in a list. One of the biggest ones is the index out of bounds. So I'm just going to say print dynamic of 10. Reasonable assumption, I said, you know, 1 to 10 here. I would think maybe that there are 10 items in the list. But let's see what happens when I do that. So I get down to that and I get this index error, last index out of range. What does that mean? That means that there isn't a 10th element in the list. I cannot go, I don't have them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in a list, but I certainly don't have anything at position 10. So even if I had 10 elements in this list, let's change this to 0 and run the whole thing again. I got more things in the list, but I still am getting my index out of range error. Why is that? I am getting an index out of range error simply because I don't have a 10th position, which means I would have 11 elements in the list. If I did this, then I'm good because I have 11 positions in the list. But if I have 10 positions in the list, I can't get here. So this is one of those things where the fact that things start at 0 and maybe you're looking at things with a range and they don't make sense, it's because that the fact that everything in a list starts at 0 can be a little bit confusing when you're first learning about lists. So let's see. Built-in functions to iterate over lists. You can go all or any or max or min or sum. Sum is very handy if you need to add things up, by the way. So I'll let you play with those. Those are all pretty easy. list games. This is just getting you familiar with iterating over a list. Now they're talking about nesting lists. Lists within a list are what they're talking about. You can have a list within a list. Now, why is this important? Well, multidimensional lists make up things like matrices, make up things like an Excel spreadsheet. That is a list within a list. So anything that has rows and columns in it is a list within a list. And you have to treat this kind of differently, because we have this concept now of something in a list. Well, what happens if I have lists within lists? What do I do? Well, this is what you do. I'm going to go to another file again. I'm going to say list and list. And I'm going to have my 2D list. Okay, oh, I can't start it with that. I'm going to have 2D, and my 2D list is going to be 1, 2, 3, 4, 5, 6. So what in the world did I just do? Well, what I just did was I created a list with 2 lists inside of it. So I have an outside list, so you'll see these. Let me make this bigger again. You'll see these outside square brackets. We know what those are. Those are for my list. Then we have these inside square brackets. So I have one set that's inside square brackets, a comma, and another set that's got these inside square brackets. And inside each of these is a set of elements, because I have a list that contains 2 other lists. So this is what a 2D list looks like, and you can have many, many, many more. Now, how do I access this data in a list? Because if I do my print 2D, I'm going to get, let me edit the configuration. I'm just going to get, like we saw with the other lists, I'm just going to get, you know, that information. So let's take a look. Let's kind of build this out a bit. If I do a for loop over 2D, and I say for item in 2D, print item, and I run this, well, now I get those 2 individual lists. That's pretty cool. And that's great, but let's say I want to get at each of the individual values. How do I do that? You do that by nesting your loops, just like your lists are nested. So what I have done in the first for loop is I have said, get me the rows, or get me the inside lists. And that's really what you see here. What you see here on these 2 lines is you see a row of data. So 1, 2, and 3, that list is a row of data. 4, 5, and 6, that list is a row of data. And if these look like rows and columns, that's because they're meant to. That's because that's what they are. So if I want to get at the individual piece of information, I'm going to say for cell, and actually I'm going to change this terminology here to make it a little more clear. For cell in row. And I'm going to print cell. So now let's see what happens. Things changed a little bit. When I was in the outside loop, everything okay? When I was in the outside loop, I got the row information. So I'm going to do and then I'm going to say just so it's a little more clear. So the row is 1, 2, and 3, and the cell is 1, the cell is 2, and the cell is 3. So this outer loop, the outer part of the loop, always will get an individual list. The inner part of the loop will get the individual values in a list. So this is how you look at nested lists. The other way to do it, and this is if you absolutely know what the numbers are, or what the positions are, you can simply say print 2D, 0, and you'll get to this because you're saying for 2D lists, for 2D, go to the 0 element, and this list is the 0 element in 2D, and then go to the 0 element inside the 0 element, and that is 1. So we will get to 1 by doing that. And then let's say we wanted to get to 2, the second element. And then let's say we wanted to get to the third element of the second list. So my second list is at position 1, the third element is at position 2, and I will get 6. So that's how you access information inside a multidimensional list. And let's go down and see. Okay, so I think we can come back and do one of those if there's time, but I really did also want to talk about the project, and we still have dictionaries to go through tonight. So, slicing. Slicing it's a notation where you can read multiple elements from a list. So Python is doing some of the work for you. So it will get you elements 1 through 3. So that's what slicing is, and it's very, very helpful. If you understand the notation very well, you can use it to save you time in coding. Modifying lists. Yeah, basically you modify lists by changing the elements. We already talked about how to modify an element, and it is, whether you're using a single-dimensional list, a multi-dimensional list, the concept is the same. You simply you get to the value of the list, or you get to the index in the list, and then you simply use it like a variable name and set it equal. Okay. Okay, so this is just saying that you can modify, and you can, there is syntax in Python which is very compact syntax and allows you to do things to the list in a very compact manner. So you can, what they're basically talking about is a line like this. So list plus fly, so basically what you're saying here is I'm creating a new list. What do I do when I'm creating a new list? Well, I'm going to have this expression. I'm going to say I plus 5, and it's going to be for I in my list. So it's going to say I is either 10, 20, or 30, and at each point in time, it's going to add 10. It's going to add 5 to each of the elements in the list, so you'll end up with 15, 25, and 35, all for a single line of code. That's great. That is a great notation, and it is very clear when you've programmed for a while in Python. This is really good if you, from my perspective, if you have a short and succinct expression. If you're going to have a very long expression, it's, in my view, better to do it longhand. And this is just kind of a Python shorthand. You can do that. You don't have to use that form of an expression for a list. You can always do it the longhand way, and it will be exactly the same and take exactly the same amount of time. Sorting lists. There's a sort function. It's really great. You don't have to worry about writing your own sorting algorithms. Python will do it for you. So if you want to sort a list of integers, it will sort it by smallest to largest. If you want to do a reverse sort, it will sort it from largest to smallest. Okay, so there are also functions like sorted, and this is when you want to go out to Python and take a real good look at the list, at what Python says about lists, because there's no way in this class to possibly cover every single function and piece of functionality that Python lets you do. There are some list functions that will return a new list and some that will modify the existing list. And that can be important if you're trying to change something in the existing list, but you used the wrong function and got back a copy. So that's just something to note. It's not really something we need for any of the stuff we're doing in the class. Command line arguments. This is something very nice about Python. You can input a comma-separated list of arguments, and it'll make it a list for you, and it's very, very handy. You can, okay, let's see. Oh, command line arguments. I'm sorry. Let's go back. Command line arguments are brought in as a list. So if you're ever writing a program where you have to take in command line arguments, those command line arguments will always come in as a list. And we kind of won't be doing that for this class, but it's a good thing to note, and yeah, it's a good thing to note. I personally don't, if I'm going to be using command line arguments for some reason, I will use a Python module like options, because it gives me so much more. So I'm going to have somebody put in a bunch of commands, but I want to do something with those commands, and there are modules in Python that let you do all kinds of things with them. So, but that's just something to mention. So these are additional practice examples. These are our labs. I'm not going to do any of these labs right now. Filter and sort a list. Dictionaries. And I know it's running late, and we will probably run till 10:30 tonight, if anybody wants to hang around that long. If not, let me know. I only see your pie charm. Can everybody else see my screen? Because I thought I shared the whole thing. Yeah, I thought I shared the whole thing. Okay, so some people see pie charm. Some people see zyBooks. Okay. Huh. I don't know why that's happening. Okay, you see dictionaries. Let me stop sharing really quick, and I'll start sharing again, and we'll see what happens. So I've just stopped sharing, and I'm starting to share again. So hopefully everybody can see dictionaries now. So dictionary is another type of a container. A dictionary is different from a list because there are no indexes in the dictionary. A dictionary has what they call key value pairs. And a key basically is a descriptive piece of information about the value that you can get to. So a dictionary would have something like, you know, age 29, height 6 feet, things like that. So let me do a quick example. Okay, let's see. Okay, everybody's good. So I'm going to just do a real quick, simple dictionary example. Okay, so this is just a simple dictionary example, and first I'm going to say that. Whoops, my bad. That. Just like we did with the list, I just created an empty dictionary. Now you'll notice that a dictionary has curly braces and not square brackets. And that's because Python just has a different notation for them, so Python knows what you want. Python knows with a list, if you have the square brackets, to expect a comma-separated list of elements, comma-separated elements. If you're using the curly brackets, Python knows to expect key value pairs. So I have just created a dictionary. That dictionary has nothing in it. But I can add things to that dictionary. So let's just do this. I'll have to do that. There we go. And I'm just going to run this. And there's nothing there. Just like when we did the list, when we very first printed that list, it was an empty list and it had the brackets, just the brackets. So this one has curly braces. So what do I do to add information to a dictionary? Well, we're going to start like we started with lists. We're going to start with static and then go to dynamic. So I'm going to say name. Now, you'll notice some things that are a little different here. First, I have this, let me do that so get rid of those squiggly lines. I have a string here, and the value in that string is name. I have a colon, and then I have a string after the colon. It's a key value pair, so name is the key, and the value is Lisa. If I want to end, so if I run this, I get name Lisa. Now, if I want to add another element, I'm going to separate it with a comma, and I'm going to say age 29. Now you'll notice something. Keys are always strings. Values can be anything you want. A value can be another list. It can be a list or another dictionary. But you want your keys to always be strings. So if I print it, I get name Lisa and age 29. So now, how do I get to the value? How do I just print out Lisa? Well, I do it like this. So we noticed with the list that the thing inside the square brackets when I was accessing the data was an integer. Here, it's going to be the key, whatever that key is. So in this case, I'm going to say, Python, print me the value from my dictionary, dict, with a key of name. and I get Lisa. And if I wanted to do it with a key of age, I would get Lisa and 29. Now, if I wanted to do it like that, let's see what happens. I get a key error 0. What in the world does that mean? That means that Python knows that this variable is a dictionary and that there is no key value of 0 for that dictionary. The key value can't be 0. There's no 0 in the dictionary. So I can't use it. That's what that means, because when you do something like this, you are accessing a list, not a dictionary. And I'm pretty sure if I did this, well, maybe I can. Maybe that key value can be a 0, and I've just never used them. Okay, it can. I can do this. I was wrong a minute ago. I told you that a dictionary key had to be a string. It doesn't have to be a string. It can be anything you want. I wonder if it can be a... Yep. It can be a float, too. You know, I never actually played with this in Python. My thinking has always been use it as a string, because that always made sense. So I was wrong. A key can be anything you want. So I could have that if I had that. So I want to give you accurate information. This is accurate information. So this doesn't refer to an element in a list. It actually refers to that. So what we're going to use is going to be strings. More importantly, what your project is going to use is going to be strings. So that was an aside. I apologize if I confused anyone. So I can, just like I could with lists, I can delete an element from a dictionary. I can change an element in a dictionary. So if I wanted to change the name to, you know, from Lisa to Molly, I could say, I'm just going to comment these out for a minute. Oops, wrong comment. Wrong key. Okay. So I could simply say, so again, like, oh, somebody, sorry. Yes, Ingrid? Okay, we're cool. So I have a print statement here and another print statement here, and in the middle I've made a modification. So let's see what happens. Lisa and then Molly, because this is how, in fact, I change data in a dictionary. And this can become important to you when you're doing your project and you're trying to remember, trying to figure out what your players may have potentially picked up in a room. Okay. Just like lists, we have methods for a dictionary. You can clear a dictionary, get rid of all the information in it. You can get the value from the key, and if it doesn't exist, it will give you, you can give it a default. You can update, merge two dictionaries together, and you can pop information off of a dictionary like you can pop information off of a list. How do you iterate, whoops, sorry, how do you iterate over a dictionary when you don't have indices? This is kind of important, and again, this will be useful in your project because your project will be using a dictionary and you're going to have to iterate over that dictionary. And basically, use a for loop, for key in dictionary. So if I wanted to iterate for soda calories, hold on. So let's do this simply. There's a couple ways to do it. So I am going to, I'm just going to, whoops, comment these out real quick. And I'm going to add a for loop. And I'm going to say for So let's see what happens when I do this. Okay, so I have basically said for every key in my dictionary dict, I'm going to print out what the key is and what the value is. So I printed key is the key for each of these. The value is dict of key, because that's how I access. Just like here, when I access dict of name, well, I can access it by this value that I'm getting from Python. So this is the way to iterate over a dictionary. There's also a way to get all of the keys, because maybe you don't want to iterate over the whole thing. So you can use let me look at that. You can get the keys by, hold on, items, keys. That's it. So if I just want the keys, and this can be very helpful, I can just get the keys, and the keys will come back as a list. Very important. Because then I could, in fact, iterate over the list, and if a key equals name, only do something with name. So that's very handy. I know we're a little bit over. So you can nest dictionaries inside of dictionaries. You can nest lists inside of dictionaries. You can nest dictionaries inside of lists. You can do all kinds of stuff. And because a dictionary is a key value pair, you would get at the dictionary inside the dictionary using the key. So I don't think we're going to use dictionaries inside of dictionaries in the projects. So 6.18, is that one of the assignments you wanted me to start? Let me double check. Okay. Okay. 13 and 19. Okay, I did go by 13, but we will do 19. Okay, replacement words. Write a program that replaces words in a sentence. The input begins with the word replacement pairs, original and replacement. The next line of input is the sentence where any word of the original list is replaced. Example, if the input is automobile, car, manufacturer, maker, children, kids, the automobile manufacturer recommends car sets for children if the automobile doesn't already have one. So it would become, the car maker recommends car seats for kids if the car doesn't already have one. Okay, so basically what you're taking in is you're taking in information that is really going to be a dictionary. Okay, this is word 1. So anytime there is the word automobile, you're going to replace it with a car. So this is the key, and this is the value, and this is the key, and this is the value. And you're just going to replace them. So let's just take a quick example. I'm not going to go through the whole thing. I'm not going to like do the input and stuff. But this is 6.19. Okay. New. Okay. So this is just going to be my reminder. So let's just take the example of automobile and car. So I'm going to create a dictionary, and my key is going to be automobile, and my value is going to be car. Oops. And I am going to just have, I'm just going to make the sentence equal to this. So what do I want to do other than put this in quotes? Okay, so I have the string in quotes. So what I can do is I can say for, and then I can say replace key, and then of key. Whoops, my bad. And then when we're done, we're going to print. And let's see what happens. Let's see if my brain has shut off after 10 o'clock, because it does happen to do that. Okay, so I'm going to run this, and we're going to see if I did something wrong. Okay, the automobile manufacturer recommends car seats for children if the automobile doesn't already have one. Okay, so it didn't replace it. Why didn't it replace it? For key in sentence.replace key, automobile, with replace of key, car. Why didn't the replace work? Should have. Did I spell it the same? Maybe I hadn't spelled it right. Nope. Oh. Okay. Well, let's go down to the bottom. Because the replacement with the same key and not the value. Ah! Thank you. Because it's replaced with the same key and not the value. So that's right. So, no, it should be. Hold on. Let me see. All right, so automobile. So replace key, replace key. Oh, it's just bad programming, Lisa. I know. It has nothing to do with the issue. But I don't like naming things the same as a function in Python. So that's why I changed it. Woohoo! Because it replaced with the same key and not the value. Oh. No, it shouldn't have. Because that's what I should have replaced it with. I should have replaced it with car. Let me try something here. Nope, that didn't work either. It's a problem with the, oh, hold on. Is it the way I'm using my dictionary? It is not the way I'm using my dictionary. It is something to do with the string replace. So that should have worked. So let's look up, go ahead. Does it have to be sentence equals sentence dot replace? Oh, you're right. Thank you. Yes, thank you very much. Very good. Why did that work this time? Because replace of a string returns a new string. So I had to put it someplace, and I did not have the equal sign. So that's why that did not work. But this is the basic gist of challenge 6.19. You're going to use something we talked about previously, which is the string.replace function, and we're going to marry it with this new stuff we have for dictionaries and this for loop for going through dictionaries and replacing things. So this is the underlying essence of challenge 6.19. So I know it's getting late. I wanted to take a few minutes, and I wanted to go through the Project 2 guidelines and rubrics and give you guys some guidance on how to do and what to do with your projects. So by now your teachers should have gotten back to you and have graded your maps and graded your pseudocode. And now you should have some more direction on what to do for your Project 2. So what can you do here? Well, first of all, they talk about, making separate functions, and that's very important because your teachers are going to grade you on that. You are going to get graded on whether or not you have your code split out into functions. And what kind of functions do you think you should have? Well, you should have functions like move from one room to the other, whatever you want to call it. But because the movement will always be the same kind of code will govern how you move and when you move that you would want to be a function. Show instructions, that's what they say here, and that's a good way to do, because you're going to have to instruct your instructor on how the game works. So, and I may want to ask how the game works multiple times. So having those set of instructions in a single place, i.e. a function, so that they can be used again and again and again is going to be very helpful. So what I would personally do if this were my project is I would start with, let me just do this. So what I would start with is, again, baby steps. This is just first thing I would want to do is there has to be a control for your program, and that control for your program is going to be a while loop. So the control for your program is basically you're going to run this until somebody tells you to stop, and that's a while loop. So I'm going to say go, and I'm going to say and then maybe the first thing I want to do is show instructions. So, let's see. I want to show instructions. That's the first thing I'm going to do. Now, this may not be the first thing you want to do in your game, but it's the first thing I'm going to do in mine. So, I'm going to define a function called show instructions. And this is where you're going to put your instructions. Now, for right now, I'm just going to copy these instructions, but you can see where I'm going with this, I think. Oh, there's a comment here, sorry. Ah, good. So until I say quit, right now I'm just going to show instructions. So why is that red? All def show instructions. They have to be named the same thing. And the instruction I'm going to say is print type quit to end the game. So let's see if this works. Again, I like going through baby steps and getting my quotes right. So I'm just going to change this. And this is going to be a sample project. So let's just check if this works. Unresolved reference show instructions. I can't see. Copy and paste right now. Now let's try it now. Okay, so I'm just going to run this really quick. And I am getting a bunch of things, so I did something wrong. Okay, what did I do wrong? Well, I set up an infinite loop, because that's what this was showing me. This is an infinite loop, and it would have run forever. Because I didn't actually give the user an ability to put anything in. So I need to say user input So now I'm not going to run forever because I have told my program to stop and wait for user input. So I'm going to run it again, and lo and behold, what would I like to do? Well, I can only do one thing right now, and that's going to be quit. That's that last thing right here. Type quit to end the game. I'm going to say quit, and I didn't quit. Well, why in the world didn't I quit? Well, that's just because I took in the user input and I didn't do anything with it. So I could type quit here 100 times over, and if I don't do anything with the user input, I won't quit. Again, I'm in an infinite loop. So if you're having infinite loop trouble like this, then what you need to do is you need to go back and see if you're doing something with your user input. So now I can say if user input is, quit, break. And I am ready to go. I'm ready to stop the program. So now let's do it again. And I only do one thing, and it's going to be quit, and I finished. So you'll see that there are a couple of instances where it's very easy to make a logic mistake that can be very frustrating. Very, very frustrating. Thank you, Chris. Yes, one was plural. So now, what do I want to do? Well, it says I can move commands. I can go south, I can go north, I can go east, or I can go west. So if my user input isn't quit, then what do I want to do? Well, maybe I want to move. So I'm going to create a function called move. And what am I going to do? Well, let's create a function called move. Now this function is not going to do much. Your function is going to do a lot more. And it's going to say print I just moved rooms. Okay? So let's see what happens when I run it again. And it's going to say, I'm going to say go south. And it's going to say I must move rooms. I should have said just move rooms. And it's just going to keep going and doing that until you tell it to quit. So what happens when I move? Well, let's go back and look at the project information again. And we see here that for their example, they've got these rooms, okay? And I'm going to add rooms up here, up at the very top, so everybody knows what they're doing. So what does this mean? Well, this means that Great Hall, if you go south, you end up in the bedroom. If you go north, you end up in the dungeon. If you go east, you end up in the kitchen. And if you go west, you end up in the library. From the bedroom, north is the Great Hall, east is the cellar, item is armor, which says the item that you collect from the bedroom is armor. So when you go into the bedroom, you collect armor. The cellar, you can go west into the bedroom. That's the only place you can go. And the item you collect is the helmet. From the dining room, you can go south. It will take you to the kitchen. And the item you collect is the dragon. So what do I do with this information? Well, I'm going to use that I'm going to put this here because the last time I went through this in the last term, everybody actually copied the name of the function, and it really drove some of the professors crazy. So this is not so everybody has to change the name of this function to whatever they want. So that's why I just changed that. So what does move rooms do? Well, it's going to say I'm coming from someplace and I'm going to another. And I always start at the Great Hall. So if there are no room, if I don't know what room I'm in the Great Hall. So I'm going to have room, because I have to give the ability to move rooms means you have to know where you are. And this would be Great Hall, room, what is it? My brain is going. Is that right, or am I in the wrong? Okay. So I have to know what room I'm in. No, did it wrong. My brain is frying. I apologize. Okay, I just need to remember what the syntax is. So it is the assignment operator. My apologies. So there's no default key value here. It's that. So if there's no room passed in, then I'm in the Great Hall. If there is a room passed in, then I'm not in the Great Hall. And what happens when I move from the Great Hall? Well, let's see. If there are up to 4 directions. You can go north, south, east, or west. So I'm going to have a direction. And there's not going to be a default. And then, based on that direction, I'm going to do something. Yes. So what am I going to do? Sorry, my bad. So you can't have a parameter without a default. You can't have a parameter without a default value following a parameter with a default value. And since room has a default value, direction had to come first. So if I have a direction, let's say it's south, I'm going to check what the direction is. So I'm just going to say if what am I going to do? Well, I'm going to move to the bedroom. So this implies something, okay? This implies that I know where I am at all times. So you might want to have a current room, and so you always know where you are. But how do I move to the bedroom? Well, I move to the bedroom by returning, what is this? I'm going to say rooms of room of south. So what I have just done is I have, and actually I'm going to print that out before to make sure we know what we're doing. Okay. I have returned, I have said, okay, I am in a room, okay, and if I haven't passed in a parameter, it's the Great Hall, and I am going to move south, because I'm going to have said go south, and so I'm going to return the room that I will be in if I move south from the Great Hall or from whatever room I'm in. Now, when you're doing your program, you'll notice that not all of your rooms are going to have a south. They're not going to have a direction for south. So you're going to have to check if, in fact, these exist. So I'm going to call that with, let's see, I'm going to call this with the direction of south and the room. Well, let's see. So actually, I'm going to do this for expedience tonight. And then I'm going to do current room. Now you'll notice that I put this outside of the while loop. And you probably want to keep it outside the while loop. So what happens, and then I'm going to say current room is going to equal whatever the next room I go to. And I'm going to print current room. So if I run this, and I say I want to go south, and it says I just moved rooms, I'm, bedroom, bedroom, because I printed it out twice, and it's going to ask me what I want to do again. And now from the bedroom, I can go north, east, and I can get something. In the bedroom, I'm in the bedroom now, and I can pick something up. So I need to have a collection of the things that I have picked up, okay? So they have to be, I'm going to pick up the armor. I'm going to pick up the helmet. So I want to have, let's say, a list that I'm going to create for the items that I have collected. There are also some other things you have to do. You have to check to see, okay, so I'm just going to put a comment here. So you have to check that, okay? You have to check if you've already picked up that piece of equipment. So potentially, you're going to want another function that's that collects this information, and you can use that function to say, okay, I'm in the bedroom, I'm collecting the things from the bedroom, and that function, maybe collect item or whatever you want to call it, will say, have I already collected this item? Then don't collect it again. Don't add it to the list again. And you're going to do that until you've reached the point of the game. And in the game they're talking about here, and so by the way, what I was talking about here is they have this status. Okay, so they're talking about inventory. This is a list. This is the list where you're going to put the things that you gather. So if I am in the bedroom and there is armor, I would add the word armor to that list. And it doesn't have to be a dictionary. In this case, it can be a list. And then you're going to allow the person to go to the next room. And you win if you catch if you collect all of the stuff before you are eaten by the dragon. So there has to be an end point to the game. And the end point to the game is whatever you have defined for your game. You defined it when you sent in the information, when you did the map and the storyboard and all of that was graded this week. So that's how you end the game. So here, it's not just about asking this information. You may want another function that determines if you're ready to end the game. So that's what you want ultimately, because you need to end this. You can't just have someone type in quit. And just because I said you can type in quit doesn't mean that's what your game should do. That's just a way that I'm giving myself an out for the game. But for your game, you have to figure out what the endpoint is going to be. Let's say it's collect all the things from the room, or it's rescue the puppy. And you know you've rescued the puppy when you've gotten the puppy and the leash and the dog bowl. And when you've gotten all those three things, and you know you've gotten them because you put them in a list, you appended to that list, then you check it, you know, and you say, okay, got everything in the inventory, great, we're done, you win. Or, you know, so sorry, you know, you got chased by a cat, you lose. Does this kind of make sense? And does this give you guys a place to start? Okay, it's starting to make a little more sense. I hope this helps. I'm not going into as much depth as I went into last term because I got in a lot of trouble. So I hope that this goes well for everybody. And I will be putting the videos and the scripts up soon, probably tomorrow. So unless anybody has any questions, then I'm just going to call it a night. Thanks for sticking around. I know it's kind of late. Okay, good night, everyone.